sure, but in China in particular, where estimates are that upwards to 250 million. It's staggering to think about this. Million people moving from rural areas into urbanized areas. And actually, my time in China makes me reflect on this as it's the urbanization moving to the rural areas and not them necessarily migrating in. Their villages are being transformed. And this effort has been underway for some time. Yeah. And so when Deng Xiaoping started to open up the economy of China, we started seeing an influx of money, development. Everyone knows the manufacturing bases started to develop in primarily coastal cities, and the migration started. So we're at a point in time where we're seeing more people living or beginning to live in cities in China. So it's a massive experiment that is going on. And along with that comes externalities. Some which we certainly could have predicted and see this happening in the sub-Saharan Africa cities and in India for sure, but all across China. You see the impacts of water pollution, soil contamination because of the way they're rapidly developing without paying it, and of course air pollution. Everybody knows PM 2.5. They even show us on their apps when we're over there. They can dial up exactly what the numbers are in their city. So and they wear these protections. So this is an environment that most of us now have never experienced for the last 30 years in Western development. So part of our effort that we're doing with the School of Design is to look at the urbanization through the lens of health and do it not just by documenting the negative things, but can we do this with a purpose? Can we actually think of design with intent of their urban form? Our buildings, our transportation systems, our parks, our recreation. How can we do this that is actually health promoting? And we see from this image here that it's a complex tapestry. There's social networks that are disrupted through this process. There's major changes in eating and behavior and activities. Lots of things change when we see this kind of urbanization. And that transformation of China, I just wanted to share with you a few pictures I just took just a few weeks ago, in fact, when I was in Chengdu. And we went out into the village areas. And I love this picture because it was a pop-up butchery. I mean, when we did our tour around the town, this didn't exist anymore. They already had chopped up the pig and distributed to the local villagers. They were curious to see me, being curious about them, as you can see from this picture. But it's just fascinating to see this transformation. So we're pointing out here is this nursery of tree growth. So the farmers are not only growing trees, but they're also growing vegetables in their own products, including that wall that you see right there on that slants through this picture. There are vegetables and cabbages growing on top of the wall, everywhere you can imagine. And this concrete road didn't exist. This little narrow path only shows a little more infrastructure being disseminated and propagated through rural areas. And this had been just a dirt path before. And walking and bicycles are still the major mode of transportation in these rural areas. Now, the changes into modern cities, everywhere you go in these cities, and these cities are not small villages at all. They're 1 million, 2 million, 10 million, 13 million populations. And they're springing up with these kind of concrete structures, high-rise buildings, densification of residential property, cranes everywhere, and bicycles have been now given up for motor vehicles. Tremendous boom of middle-income populations using now affording cars and motorized scooters and motorcycles, as you see changing here. All the way to the super modern cities of Shenzhen that from the 1980s to now is now 13, 14 million people. I think the third tallest building in the world is in Shenzhen. And this is a picture of Shanghai and the modern look to that city. And of course, you can't go very far in China without finding our roots, right? Our roots right back to things that for a worried tourist like myself, or not hardly a tourist, we're over there doing some research with them, but They always let me stop at the local Starbucks. I love this picture, Linda, because look at how they did this. This is traditional Chinese architecture with the Starbucks nested inside of it. It was very welcoming. So in our work in China, we're doing it in several cities, but we're really sort of adopted and took to heart this small town, and it's like a fourth tier city, 500,000 people, and it's going through development. It's in Zhejiang province along the east coast of China. You can see it located there in red. Yujing is this small town, and it too is growing. It's not going to stay a small town because it's just north of Guangzhou, which is a major manufacturing center in China. It's a 50-minute drive from Guangzhou, and it's sort of being pushed. You're seeing the suburban complex, but built around this city. And here's a vertical plan view of the city. You see the rivers that come down from the mountains that fan out into this delta before going out into the sea. And traditionally, all the rice paddies were taking advantage of this flow of fresh water. And the city is back to the upper left in this picture that exists. But I have put an oval around the major development that is being planned by CP Modern Living. And this is a private company that has bought the rights to develop on this property. The rectangle is the first phase of this. And I like to title this From Rice Paddies to Houses, because this is what is there now, and it is going to be transformed. And you see the city behind, you see air pollution drifting across the horizon here, and that's going to be transformed into some built infrastructure that looks like this. So high-rise dense, villas, low density residential, commercial properties, recreational properties, maybe even some sports centers and civic centers are going to be built here in this phase one. But when they build out all three phases, this is going to be 200,000 people. So this almost doubles, half again, the size of the existing city. So the question is, what happens when this? Lots of things changes, as we've already alluded to. But let's focus, Linda, today on the issue of carbon sinks. Because when we build infrastructure like this and build it on land that isn't previously industrialized or used, a brownfield or something, it usually comes at the expense of vegetation in some form or another.
Right.
So take us into this carbon balance sheet. That's what your thesis was about, and this is how we're going to apply it here.
Oh, terrific. Thank you, Jack, and thank you, Emily, for inviting me to be part of this webinar series. This is really important to be looking at our loss of carbon sinks in the context of urbanization, because there's many trends going on here. And as we begin to, well, actually, I should say that this is the publication that came out of my initial research on Connecticut, the state of Connecticut. So I was looking at the changes in land use policy, and particularly the loss of forested areas in my home state of Connecticut, which is a heavily forested green state, but with the same development pressures that are occurring throughout New England, and how that matches with the estimations of our fossil fuel emissions and how the two marry together to form more effective climate change policy. So that was published in December and is available online. But what is really interesting, we should begin our discussion with how vegetative carbon sinks and the potential for carbon sequestration affects even the short-term balances for atmospheric carbon. And so this is the classic Keeling Curve, which we're all familiar with, that shows the 50-year trend in the rise of carbon dioxide in terms of measured parts per million that came out of this monitoring station in Hawaii. So while we're familiar with the trend line, we often don't analyze this sawtooth jagged line that accompanies that. So what this really represents is the amount of atmospheric carbon that is conditioned by the sequestration uptake in both the northern and southern hemispheres. So these red points that are above the line represent an overall rise of carbon in excess of the trend line, which is in the warm season, so the months where the southern hemisphere would be in fluorescence and uptaking carbon. But because the land masses of the southern hemisphere are smaller than the land masses of the northern hemisphere, they uptake smaller amounts of carbon and therefore push the bounds of the atmospheric carbon
So it goes
above
up,
the
goes
average.
up in the atmosphere because less is being taken out.
Exactly.
Yeah.
Where in the warmer months of the spring and summer months here in the northern hemisphere, we have a greater amount of uptake of carbon, and therefore the amount of parts per million actually decreases vis-a-vis that overall trend
When you
line.
see the swing of 5 parts per million, that in the atmosphere global, this is a big impact.
Right, this is
Yeah.
significant, and I think this shows us why we need to be looking at this carefully. There's another way of looking at carbon sources and carbon sinks, and this is the classic image of the bathtub. So our sources would be anything from fossil fuel combustion that we are adding to the atmosphere, which is the base of the causes of climate change, which is the rise of CO2. So if we think of everything going into this bathtub as being the water, so not only our fossil fuel combustion, whether it's from industry, commerce, transportation, but it's also quantified by deforestation, which really deforestation worldwide is estimated to represent 1/4 of all the emissions. So we're adding sources in the method of deforestation, right? But at the same time, we need to think of those forests themselves and the vegetative biomass as the carbon sinks that pulls the carbon dioxide levels out of the atmosphere. So by removing the sink, it's the same time, the same idea of stopping up the bathtub because you're blocking the drain. So your sinks of carbon would be the drain. So if you add these two together, an increase of water, but then a decrease in the outflow, you have a rising level of carbon dioxide in the atmosphere. So what we're going to do is take apart these sinks a little more. Well, you have in the two sources of emissions that we discussed, the preponderance being the burning of fossil fuels, but also about 1/4 coming from deforestation. If you look this to the right, this would be the opposite effect. Where is the carbon going and where is it being uptaken by the earth? So a very large amount is going into the oceans. And so we have the ocean being the largest bathtub source, the drain there. So oceanic carbon levels are rising, as we know, and the acidification of the ocean, so which is a cause for concern in and of itself. We have a little less than half of this being absorbed by the atmosphere. But we have a third very large proportion being uptaken by our vegetative biomass. So these are everything in the form of trees, grasslands, wetlands particularly. Wetlands carbons contain, or wetland soils contain huge amounts of carbon, often several multiples of what would be soil carbon in forested landscapes. But look at the wide parameter here of uncertainty that surrounds this number, which points to the fact that more research definitely needs to be done on the carbon values that come from our landscape. Okay, now we are going to grow a tree. Okay.
Oh, that's quick.
Okay, that would be your classic 20-year tree that we have in China right now from the plantation. So going back to our elementary school biology, what we have is the principles of photosynthesis and trees actually drinking in the carbon dioxide in the presence of sunlight with chlorophyll. So this is how we are having the carbon sequestration occur. At the same time, these trees are respiring carbon dioxide as autotrophic respiration here. And of course, releasing carbon, uptaking the carbon, releasing it as oxygen, purifying our air. We have then the fixing of carbon, which is the transformation from the leafy biomass into the more carbon-dense parts of the tree, which would be the trunk and the heavier branches, which is where most of the carbon will be stored. We have, with the seasonality and the loss of our deciduous leaves, falling is leaf litter and deadwood that, especially with our storms ever increasing from climate change themselves. And that becomes a second form of a carbon pool, which is your dead leaf and wood litter, which is the top level of the soil, transforming itself into humus in over a 7 to 9-year cycle is decomposed to become part of the soil. And then some of that is released also by the process of decomposition into the air. The leaf, as they decompose, as I said, become part of soil organic carbon. We have the below ground biomass, which is the roots, and through root mortality also becoming, again, part of the below ground soil pool. But what's interesting is that the proportion of the roots or the below ground biomass is actually almost half of what the above ground biomass would be in northern latitudes and in especially where we are here in New England. Whereas when we go to China, we'll see that it is less than 30%, so really 0.28% versus 0.46. And this is really typical of when you move into subtropical forests, that the overwhelming amount of carbon is stored in above ground biomass. Okay.
So that's why I just want to point out, so when you till the soil by agricultural practices, you actually get to this decomposed carbon and release it quicker.
Exactly.
Yeah.
That's exactly right. And so that becomes a sort of subspecies of carbon studies itself on tilling practices in order to retain the carbon. So we have, again, how are our forest sources looking right now? We have above ground biomass here, we have below ground biomass, soil organic carbon, and then we have the dead leaf and wood litter. If we chop down this tree, we're not only losing the amount of carbon that is sequestered actively, but then we are releasing carbon into the atmosphere. Although some carbon is retained through timber reuse, either as lumber for houses or as furniture, or especially outdoor furniture is a good use of some of these tropical forests. Not the rare species, but the plantation forests. But you have the big problem of the permanence of carbon dioxide in the atmosphere, which is why every time we talk about cutting emissions, it is not the solution, the overnight solution to climate change, because of this 100-year permanence or half-life of carbon dioxide in the atmosphere. The origins of my research are in the home state of Connecticut, which is a coastal state in New England. Here we are. You can see it on the northeastern section of this map. Also, it is to the right, you could see bisected by a large river valley, which is where the development has occurred historically, both agricultural and then now as population density. But there are many similarities in both the size and I think lessons to be drawn from a scale, a unit of analysis, the scale of the size of Connecticut, and how we can use some of these mapping and scientific tools to draw some of this study. This is what the northwestern part of the state looks like, and this dense forest land is captured under the protection of a state forest, but it's also where the famous Appalachian Mountain Trail passes through. And so I took these photos during a hike in the fall. And this is another representation that also shows us the agricultural legacy of colonial settlement, beginning with the 1600s and then went through the early part of the 1800s. So these cleared areas, which would be where you would have historically have had agriculture, herding, and so some of these areas have been preserved. This is a farm in the area. But again, the beautiful colors of fall and this lush vegetation are real treasures that don't want to be lost to unplanned development, which tends to be, in this photo, as you could see from the state of Connecticut, often piecemeal. And so when you have this piecemeal and incremental loss of forestry to single developments, smaller both residential developments, but also the infrastructure that supports and connects these developments through suburban landscapes, what you have is development pressures that result in very inefficient land use. So very quickly here, you could see on the mapping, you have over the course of 30 years, maybe a 10, 11%. Okay, 10, 11% rise in the population right here over 30 years, but you have about 110% rise in the amount of land use that is consumed to support the development, settlement, and the infrastructure needs of that same amount of population rise.
So I guess from that picture, it's clear that it's not just the footprint of the house and the yard. It is everything else that goes along with it.
Correct. Yeah. So again, it's low density residential development and all of the infrastructure and the commercial development that supports burgeoning suburban populations. So I'm looking at a research question, given these points of losing the beauty of one's home landscape. But the question becomes here, if you could use both the science that is available and the knowledge of the carbon pool assessment methodologies of the satellite imaging and other things that are available through NASA and computer modeling, if we could come up with a quantification of the sequestration values and then put some actual economic values on the land and on the forest as well, that plays into a wider range of policy options when we begin to address climate change at the regional level. So very quickly, here are some of the research objectives in proposing this type of forest methodology, which would take into account the loss of the sinks from forest and other biomass loss. One is if we could put a sink value on this land-based biomass so that we could see what is it worth in relation to the larger picture of emissions and sequestration. Two, if we could determine long-term rates, so trend lines for both the positive gains that are made in sequestration, but also the losses with the disappearance of either forests or other types of agricultural land, as we're seeing in China. Three, if we could quantify this, so we have a ratio of how this carbon capture figures into a larger profile of greenhouse gas emissions over time, to look and see if this methodology does apply elsewhere, and this is the study today in today's webinar for China. But then also, and the most important thing, is how do we use these conclusions and research methodologies to come up with more appropriate and often cost-effective public policy applications as we turn to climate change policy, both at a global, a regional, a state, and often a local level. I will quickly walk you through the methodology that I used to arrive at some of these numbers for the dissection of the points that we just looked at. What is available to everyone is this wonderful INVEST modeling program that was developed by Stanford University at the Institute for the Environment. And it's called the INVEST Program for Environmental Services. I use the carbon storage and sequestration model, which gives me simulation software so that I could input the on-the-ground values of both our landscape and land use profiles of the various land use categories, but also valuations of carbon pools, which are the scientific numbers that have been done by various researchers as to the carbon contained in the pools of above ground, below ground, soil, and the dead carbon biomass, which are really the inputs that are required to run this program. Very lucky I was for the state of Connecticut that the University of Connecticut Center for Land Use Education and Research had really performed the maiden studies on this and partnered with NASA in the early 80s to capture some of this incremental forest development incursion into our home state forests, which is what initiated this research. So on the left, you see what would be the raster data of the various land use categories and how these change both in terms of acreage and then square acreage and then as a percentage from year to year. And they did this over 25 years and are now working on the 2015 data to bring this up to 30 years. And this is the longest history of land use change and patterns that have been measured for any state in the country, the United States. Now you're asking what the... Right.
Yeah, just quickly take us through the what you get from the satellite data and what these color renditionings imply.
Right. By transforming these satellite imageries into readable color patterns that represent the various land use categories, you could see right away that the green in this represents, in this case, the deciduous forests, which cover most of the states, the coniferous forests, which have a higher carbon density. But if we look around those, there's agricultural land represented in the brown. The yellow, believe it or not, could be it's turf grass. So these could be both residential lawns or they could be golf courses because that dense manicured turf grass has a larger reflectance and actually has a quite surprisingly high below ground carbon sequestration level, which is higher than wild grass and definitely higher than agriculture. So the red, of course, is what we're concerned with, and this is the urban development. And we're going to see these patterns not only in Connecticut, but particularly in China. Okay. This is what the mapping looks like across 25 years. And so if we were to compare here, if we were to compare the urbanization of this central river valley area and the corridor that runs down to the commuting corridor into New York City, we'll see an amplification of that urbanized area, and particularly the infrastructure connections as highways have been developed across the past 25 years. And of course, sort of the milder climates along the coastline are undergoing some development too, which brings up its own questions as you develop coastlines, both for coastal resiliency and also the loss of some of the flood control mechanisms that the natural environment and sand dunes, et cetera, inland wetlands play there. Okay, quickly, some of the methodological tools, just to show you the rigor of the research, is that we look not only on the different types of forest species that have different levels of carbon uptake, but also how they're divided among these 4 carbon pools. So these are the most abundant species, and this represents really the proportion in which they existed and the proportion that each carbon pool contributes. Here's a window for the sequestration model provided by Invest. So what we're doing is putting in through the raster data sets current and future uses of carbon to see and to model and to compare the rises and losses. In the question of Connecticut, it was consistent losses of carbon from one modeling year to the next. And this modeling spits out very precise, down to the hundredths or thousandths of if you wish, milligrams of carbon captured through being sequestered by these land use categories. Again, very quickly, these are the sensitivity analysis that we ran in order to anticipate any over or underestimation of either our carbon values or perhaps even some misclassification of some of those land use categories. But this does nothing more than show how we arrived at these numbers. These are not randomly generated numbers, but running through our input data into the INVEST program, what it did show us that we have a loss here of, without biomass growth.
Really. Now this is in metric tons, not because it all adds up. All the grams add up to metric tons, right?
Exactly, exactly. So what you have is actually million metric tons, and for the state of Connecticut, over that 25-year loss, even measuring statically, without accounting for the growth of this plant value, we had 38 million metric tons cumulatively over 25 years. So what we are to look at is this, coincidentally, for 2010 was the exact amount of fossil fuel emissions, which are 90% of the carbon emissions profile for the state. To show you more on how our measuring took place. Okay, and so this is represented in a series of maps, which I think this is the most illustrative.
And you run over those other slides quickly, but they'll be up on the PDF, so everyone can go back and look at them in detail. But this summarizes the body of the research.
Exactly. These are 2 sets of graphing that I think illustrates very, very concisely how our numbers play out. So if anyone had any questions, you can refer to those that are on the will be on the website, but I do want to get to the China research here just to go through. So what we have here is approximately 40 million metric tons of carbon dioxide. So across these 25 years of emissions, which rises and falls slightly, but hovers around that 40 million metric ton level. In contrast, you have this rise of sequestration due to plant growth. But remember, these are lost forests, so lost vegetative sequestration. But had they remained over 25 years and plotting with the addition of biomass growth, we would have come to a point of net zero emissions about the year 2002. And everything after that would have been incremental gain. That would have nullified the emissions.
So it strikes me, Linda, that even though the population has increased by 10%, the total carbon dioxide emissions remain roughly level over that time period.
Exactly.
Conservation, what is this?
Interestingly enough, we have put in energy efficiency measures, which will, since 2008 particularly, when some of the major state climate change legislation went into effect, much more aggressive measures have been taken to address especially building emissions, as you know, that are about a third of the profile of a state like this. Some transportation emissions, but through energy efficiency programs and through the conversion also to natural gas, which is less emitting than petroleum and gas, that we are going to see a greater, I would think, a leveling off at least, and maybe a slight dip. Also, some of this has been conditioned by a weak economy. So, and high gas prices, which have actually cut into transportation emissions. But what we're seeing here, again, is another way of looking at it, is you have the light blue is a leveling, more or less, with slight dips and rises of the emissions profile, in contrast to rising sequestration levels that were lost, of course, to deforestation. So you would have had in 2002, again, this net zero carbon point, and then everything after that would have captured as net carbon positive. And of course, this would have been a continued rise to the point research is finding, scientific research on conservation biology, of maybe 150 years of sequestration and beyond. And this is some of the research coming out of the Harvard Forest, as a matter of fact, David Foster and others that are coming up with this research now. Okay, let's transfer our attention to Zhejiang province, because this is really the point of the HAPPY project, to look at health and health in the context of environmental gains and losses and urbanization in China. So Zhejiang province is, like Connecticut, a coastal province. It measures about 102,000 square kilometers. It enjoys a mild subtropical climate with some monsoon seasons, so the humidity and the rainfall greatly propels the growth of biomass in this area. And we have a really ideal climate here for forest plantations and forest growth. I'm going to quickly go through the research methods just to show you how they differed from the ready data and satellite profiles that I had to work with, which were in Connecticut, which were already prepared for by the University of Connecticut. This was very much a grassroots, I should say, a ground up. We had a bottom up method that we had to develop our own Landsat data files. So you're starting with these NDVI indexes that come from Landsat, first 5 and then 8. And 6 and 7 had failed, so we have a gap in a few years. But the Landsat 8 particularly has a degree of resonance that is just beautiful for being able, and very precise for being able to look at the conversion of urbanization effects on the landscape. So we're retrieving bands of a specific wavelength. On the left is what you look like. This is ArcGIS modeling. And then we're converting them to ISO clusters. So either using 15 or 25 ISO clusters, and then grouping those to represent either 4 categories. Water, we've grouped croplands, and grasslands is the yellow. Urbanization is always in red. And then the forests, we put both coniferous, deciduous, but mixed forests as the green, because it's very hard from aerial photos to distinguish one type from the other. But compiling this over your base map, you can see very easily which would be your developed areas. And you not only see individual buildings, but you see individual roads and networks of infrastructure. So there's really no doubt when you're going to make these conversions. The carbon stock values, similarly to the New England forests, came from anywhere from 100 to 150 published scientific articles that are specific to Southeast China vegetation. So these are not national values or average values, which would clearly be a misrepresentation of the potential for carbon sequestration in the Zhejiang province area. These are specific to subtropical forest and growth potential, which is the more important thing, because we have not only the 4 carbon pools, but we also mapped out carbon sequestration. And so that's annual growth rates. The range of values available to us was vast, but we erred on the conservative side, always picking lower to mid values so as not to over-represent the sequestration potential. And so just here's the idea of article after article to find where these values started to line up so that they wouldn't be random. So what we come out with here is our own mapping based on the Landsat tiles and the base imagery of urbanization growth and the change in landscape patterns over 1 decade here. So you can see, particularly in the landscape, the river valley of the Yangtze River Delta to north, where you have a great supplanting of agricultural lands with urban development, obviously, because of the ready access of the transportation networks, the climate, and of course the flat land. And the other area you're going to see this is along the coastal regions here. So particularly these larger cities, Wenzhou area, the Yuxing area, it would be right here on the southeast of China. And at the same time, you're seeing a parallel change in the landscape, which is what was a surprising and differentiating set of conditions for this study and the changes in landscape value. At the same time, the national government of China was providing economic stimuli to the development of industrial areas along the coast. Beginning in the mid-1990s, and Zhejiang province was made a target of this type of economic development strategy for industrial and coastal city growth. There was a parallel strategy for economic development, and that was afforestation and reforestation in order to develop the forest sector and the timber through the aggressive planting of forest plantations, principally of pine forests in the interior. And so what you're seeing really is a filling in of these interior, what would have been either grasslands or open areas with really the intensification of the forest landscape. So what would have been spotty green areas mapped out, now they are densely forested. And that is going to be the major takeaway from this study of landscape change in Zhejiang province. By comparing in a normalized set of values, the relationship of one landscape category changing in relation to another, you can definitely see the rise of forestation here. Now, this is not the carbon sequestration. This is just the prominence of one particular land category or land value against another. So I'm imagining at the beginning of the 2000s here, take this area, of this decade, we have a continued downward trajectory of forest neglect and also some type of forest degradation. You have subsistence agriculture, again, cutting into that. But the policy that I had mentioned of reforesting the landscape in the country areas is, after 20 years, begun in the latter 1980s, early 1990s, basically 20 years of 20 years of forests reaching a point of maturity that they can begin to register growth that are captured by the satellite imagery. So while they're growing here, they're really not dense enough to be reflected in that type of satellite remote sensing. So what we have is, and I imagine some of these, this could be a type of error that is on the landscape tiles. Could be cloud cover in that particular area. So we're not saying that it actually dipped down in that area or grew less, but this quite honestly is maybe a more steady trajectory of forests, a continued rise of urbanization, which we all know to be true, as you know from your travels and on the ground. But the other thing to point out is a loss of agricultural land over time. And so what this will mean for the Chinese in order to feed populations that have migrated from subsistence agricultural rural patterns into the cities where they're not growing their own food anymore. Okay. So here are the big conclusions. Okay. While these are first principles, we have to mention these are central principles that require more exploration, of course. But the trend patterns that are the results of this research is that we have a rise in carbon sequestration across the past decade only, 2002 through 2012.
Just the opposite of Connecticut.
Exactly,
right?
exactly, owing to this interior reforestation. But that's a rise of 25% in just one decade, right? That shows the success, unintended or not, in terms of climate change policy and carbon sequestration, but certainly the success of the reforestation program. We're going to compare that with research that is coming out. Again, some of this is from the China project out of the Department of Chemistry here and Engineering at Harvard, and measuring not only emissions that are on a national level, so the macro level of China, but breaking down the emissions by province, which is really important because industry tends to be concentrated, partly owing to the economic development policies of China, but also as a result of urbanization as itself. So as people urbanize, think of how lifestyles change, where they might have been in a much more modest residential setting in the countryside. Now they are in buildings that are not only heated, air conditioned in many cases, but as we move up on with economic scales and the growth of the middle and middle to upper class in China, what you have is an appliance load. What you have is a technology load.
Motorized transportation, not bikes.
Exactly.
More Starbucks.
Exactly, all of the above. So the per capita emissions is going up vastly, as well as the overall emissions per province. So these two things factor together. Of course, look, you're seeing almost a quadrupling, almost of emissions in Zhejiang province across the decade. So while you look at this, the rates of change, when you're talking about numbers this vast, how do you put this in context? I couldn't make a head-to-head comparison as you did for Connecticut because you did not have emissions equaling the amount of sequestration, but you had tremendous growth rates. So the change rates is what matters here. So the red star, this is the modeling of the growth in sequestration that we just saw. The change rates and how rapidly emissions are rising in the province of Zhejiang. But at the same time, even though we have a rise of sequestration, there's something of an asymptotic curve there. So the rates of change will not be able to compensate exactly for the rise in emissions. And I think that's the key takeaway for Zhejiang province. Okay, so what will this mean in terms of fiscal implications? Said at the beginning, it's important that we can start to quantify this and put a price on what this means as we especially look at very costly climate change policy. What will this mean in terms of looking at forests as a vital component and strategy tool in order to realize more balanced emissions and sinks in trying to line these, certainly not in parity, but in a way that can make a dent into rising atmospheric carbon. So first of all, we need to give greater sensitivity to ecological design. So where we're looking at planning in other tools through forests and through the maintenance of vegetative biomass as a carbon tool that goes well beyond flood control, hydrology, water purification, some of the things that we traditionally attributed, but also add in carbon sequestration as a quantifiable environmental value. So that's what we said, give the forest an increased value where you can actually put a price on this because there's an outside market price per ton of carbon. So this is not an arbitrary price, but it's a universally recognized and fixed price you can give to local forests. The whole idea now, this forest conservation and afforestation, even though it was originally meant as an economic tool, gives us more options in regulating carbon. So we can look at carbon addressing climate change and carbon cuts in emissions with a wider range of options that are not just on output, but also looking at uptake. So there's some also fiscal implications. If we start to talk about taxes on carbon output and on carbon taxes, why are not we discussing the flip side, which is the loss of carbon sequestration, which is just as important as cutting emissions? Similarly, there's environmental policy implications for the forests. So as we just saw in my last chart, even though we have rising sequestration levels, these rates of sequestration are not keeping up, particularly with the per capita emissions rises as populations urbanize. In Southeast China, it's very evident both in the mapping and then in the quantification of the emissions rates. Second, although there is some, we need to consider that these rates of carbon sink change need to be looked at in the greenhouse gas inventories, which if you only are looking at emissions, and land use change often is accounted for, but perhaps in terms of herding, farming, as you say, agricultural loss of emissions from tilling and other agricultural practices, just the idea of having forests preserved and accounting for this in greenhouse gas inventories gives a more robust picture of what's actually happening in terms of climate change. Then there's some hope here. Is that the preservation of these forest stocks is the determinant factor in order to exercise some influence of biomass carbon sequestration. So preserving them, replanting, and this is the policy trajectory that China is showing here, provided that there are not downstream effects elsewhere, or I should say upstream by sourcing timber aggressively from other parts of the world. But here's the rub, that the young age of China's mixed forest plantations, basically we're looking at 20 years where forests are just now reaching their point of maturity, but these are the first succession the first successional species. As these transition and succeed to second successional species, these will be larger in terms of above ground biomass as the biomass itself expands, but they'll also transition to more carbon dense secondary species. So again, what we're looking at is as the asymptotic curve will actually rise in terms of the y-axis, and then we're going to be talking about much more robust rates of carbon sequestration that could be over the next 50 to 100 years. So that's the hope and then that is also the justification for further research into this biomass area. Okay, well, thank you for allowing me to present.
Yeah, thank you, Linda. And we have a couple questions. We have a few minutes before we need to conclude. One is, you just touched on some of the policy implications for the research in China. And in the introduction, Dr. Spengler alluded to some actual policy change as a result of the research in Connecticut. And I was wondering if you could touch upon that a little bit more.
Oh, thank you. Yes, the state of Connecticut has been really responsive. We have a combined Department of Energy and Environmental Protection, realizing that clean energy is also goes hand in hand with a clean environment. So the idea of looking at alternative forms of energy efficiency, but particularly accounting for the land use change, was compelling enough when you start to look at the numbers. So not to continue to overlook this. What happened is that our greenhouse gas inventory for the state of Connecticut uses the EPA SIT tool, which is called the tool for modeling. And so these are sort of default programs to account for land use change. But because it was yielding inconsistent values year after year, it was felt not to be reliable. Looking at this methodology that I presented this morning as a quantifiable way to see what's happening to our forests and to make land use change an actual part of the next greenhouse gas inventory, which I'm really thrilled about.
That's great.
So I particularly I get the salient message here that with a strong methodology, and even to the regionalization of those sinks is it's so important that we have a quantitative tool to value nature and put it into our economic accounting system, which we're often forced to do, to say that, listen, this plays a critical role in going forward with carbon management in the future. The other thing that I wanted to note, Linda, as you were talking here, is the loss of agricultural land in Zhejiang province, probably offset by development and forestation. But China's now, the breadbasket is Latin America. You know, it's growing in terms of soy production, soy and corn and others, and Africa too. So, you know, when the real global accounting system needs to really consider this holistically.
Exactly.
You know, so,
right.
So where are these major carbon flows across our oceans going? You know, it's we're buying products from China, so effectively we're driving their carbon emissions through our purchasing. They're buying their food like we did, and certainly are buying in the international markets, buying our commodities. So.
Exactly, and that factors in where's the upstream deforestation. Because if you're going to plant local carbon, local cropland or reforest it, but you're purchasing soy that has come from deforested Amazonian areas, then we're talking about, again, a global loss of those same resources we're hoping to preserve locally.
Right, and the good news is Brazil, you know, one of the big bread baskets for China, is putting a restriction, no net deforestation for agricultural production. So if these take place, then at least we start to balance the ledger. Let's put it that way.
Right.
Yeah.
And it's these quantification tools that bring at least the attention to the magnitude that they're exercising, things that forests are exercising over the carbon budgets, which prior to the imaging we had and some of these modeling systems, it was just a rough estimate. And now we have precise numbers. And numbers cost, as these resources also can be assigned values.
Yeah, great. And one last quick question. Linda, can you talk about the next steps in this research? Where do you want to see this going?
I think this is really important because in terms of Zhejiang province, I was really surprised. I didn't anticipate this parallel policy development for the reforestation. And I thought that was really exciting. And so what I would like to do is refine particularly these numbers, and I said there are first estimates here, but to go over one more time and to see what could be the long-term trends in the forestation, in particular where you say the maturation of those forests. So hoping to package this up, obviously, and then publish this as well. But I will be going to China next week as part of the HAPPY project, and to meet with local environmental policymakers and to share that in the same way I was able to share it with Connecticut policymakers, and to bring to their attention why this is important for the healthy growth of urbanization in cities.
Now, hopefully she'll have a good reception there, because a year ago when I was in Eugene starting this project, we met with the mayor, of course, and the vice mayor and other dignitaries and department heads of the city. And the vice mayor, I got chatting with him. He's a forester. He
Nice.
was 20 or 30 years. That was his prior work. We talked about hiking. We talked about the forest around Eugene. You will have someone that I guarantee is interested in what you're doing. So,
Beautiful,
yeah.
beautiful.
Yeah. Well, that's great. We're going to have to wrap it up, but I want to thank Linda and Jack for their presentations. This was very informative, and I'd also like to thank everyone that joined for attending. I want to encourage you to check out our website to access the recording of this webinar, as well as the PowerPoint presentations and the copy of Linda's research that has been published. So that's all available on our. We also have information about upcoming webinars, including one tomorrow, which is on planning and design guidelines and prototypes for healthier places. So thanks again to everyone for joining, and we hope to see you again soon.
Oh, nicely done. Yeah, that's